Start recording. Welcome back. I'm Michael Wickerson, Wickerson Studios. We're going to jump into Wickerson's favorite scripts, but these are actually going to be a private repo, and they're modified scripts. I just can't remember back to this first script that I modified or worked with, whether it was Daniel Christev's idea or mine. But since I think he's pretty cool, I think he won't mind me kind of putting this in here as a modified script. Let's run through it and take a look at what's actually happening here. Nice and easy off the start. I've got a point in here, actually multiple points, so it's making me think it's Daniel Christev's because I doubt very much I would have started with points, multiple points as an attractor, but basically building a hex grid. Hexagon grid, rotating that grid to get it organizing, exploding it so I can get at the vertices and the segments, setting up tree data. And the more I look at this, the more I think possibly it came from Daniel Christev. A sense of list items, one side, the other side of the curves, the points within them, and then the list items of those points, the points outside and the points here. And what I did was I just kind of played around with these to see what I could do with them. So I drew some lines between all these ones, drew lines between these ones, and I ended up finding the points within those by curve intersections between these 2 points. So you end up with these nice points in between, and then the distance being measured between them and those other points, putting through a bounds and reparameterizing through a remap numbers, I guess not reparameterizing, remapping, creating a vector 2, which you won't be able to see unless you actually wanted to go into your display nodes and take a look at those vectors and see if they wouldn't come up. I think I can make them a vector from their own point, but I have to grab them from points to see those vectors, and there they are moving off in that direction. And then using those, amplifying them, moving them into a direction which is actually, I believe, up, which is nice, not just moving them off, that I could build these nice patterns from it. So a nice system, and here are the other patterns. And so from those two patterns, you can close your rep, and you can do a little rotation with them, which is kind of fun. And maybe I should add a 0 to 2.00 just to modify it and see what happens here as I start to spin those around. There we go, start to play with them. That's kind of nice. And then close the rep on the final form. And I think I probably modified and played with it a little bit and matched it. And we go back to the original thing. You can see that you end up having different sizes, which are not so exciting. Let me pull out all the geometries as we go in the vectors. And then those points are the ones that can actually drive, if I move those points around, I think they still, let me just grab them all and use them to pull. I guess I'm just pulling one at a time to change the shape. I might have them internalized, so I might have to go in here and set all those points again and see how they affect. Well, let's just select 5 new points, and there we go. They should have changed the form a little bit because that would have affected a difference in that. What happens when I play with these? Thinking about how much control I had over them and the patterns within them, keeping the originals and playing with these. I don't know. I'm thinking it's a Daniel Christev script that I was just playing around with and messing with, playing with these list items. I don't think this is going to change much, just alternates the vector, pushing in different ways, and then you're left with that X and Y extends to make a pattern. And I'm pretty sure there's an attractor point affecting how those open and close. That would have become more complex, but let's just jump in and grab another one after that. I think I gave Daniel Christev credit for this one as well, because taking a look at it, it was early design-based work, and I doubt very much, taking a look at it all the way to the end, and the brep, there it is. This looks like something that Daniel Christev would have dreamt up as an amazing surface. I may have cut and divided it in a different way, but there's some really nice tools through here. Download, and because it's a download mesh from points node, that's something I like using quite often. So what this is a domain and a domain that are run through a graph mapper to give a surface. There's a really nice use of a cross-reference, some multiplication, which I don't use those nodes so much for the cross-reference, to build a point system. And from that point system, I'm pretty sure we're going into mesh surface from points, and you get these really nice surfaces. And then splitting up that domain again into the ISO curves, so the ISO trim, you can start to separate how many you want of those to subdivide those surfaces, and then, and it's kind of slowed down because I made a big count, a second ISO trim. So an ISO trim to another ISO trim with a divide domain 2, and it looks like Daniel Christev was one to implicitly put in this x plus 1 into the function node to get the tops. So that's kind of nice. And changing the size of those surfaces to what you want as a domain. And then projecting those down onto the bottom and lofting between the two. So that makes sense to me because that's something that I do quite often. And then pull them into one final or multiple breps in the end and you're done. Really nice script to have a surface that's actually this wonderful little world that you can make as complex as you want. Let me lock that solver and bring this one down. And that should make it a little simpler and run a little faster. And let's just check the profiler on this last one. It's under 100 milliseconds, so I'm okay with that. It's pretty close at 99. So yeah, I think this was my first scripts and really driving what I thought was interesting about Grasshopper. And then I think I really do move off into my own. We're going to take a look at these top 10. I love this script. I can't say anything more about it. I absolutely adore it. The simplest way to write. Now I've packed that into a Python node and a C# node, but you're basically coming in using the simplest things you can. A range. I don't even have the display on full names, but let me do that. And you can see that you have a curve that's coming from a point system that's making a helix from the sine and cosine out of a range, and the domain is defaulting from 0 to 14 as a length. I guess you, and I've got a point count that can really kind of flatten your curve and mess it up if you don't have a high enough point count. But I really have used this node. It was one of my first development I did for a jeweler, just to build this kind of curve that could drive geometries. And I don't think I've really evolved past this simplicity of how I think of Grasshopper computationally. But I put that script in there because it's one of my first scripts and I love it. The next one, if we continue along, we're at 14. I think here, this is probably just an interest of stacking bricks in my backyard. So let's just jump there and see what's happening. That's exactly what it's doing. It's a system of pulling out bricks and stacking them and rolling them and moving them. So it's a nice little script that you start with your polygon. I've got such a high count you can't even see that that's actually, you know, a polygon of shapes. I've got a count on here. I'm finding the centroid to each one of those. And then let's just grab a bifocal so we see what's happening here. Move away from is a really nice node, and I never ever used that except for the script, and it's a wonder I never went back to it. A Euclidean tool right here. Move away from seems to be something that I should have used more often, but a geometry, an emitter, and a distance. And then dividing that curve and dividing those point curves, drawing a line between them. That's kind of setting up where those are lofting to build those kind of bricks that come out. Extruding those bricks, using a linear array to draw that up, and then I think what I'm doing is dispatching every other one and just giving a little roll rotation on moving one to the side. So that's one that I've done with the radius, and then the other curves. So you got these curves and you got these curves, and when you bring them together they form this kind of brickwork that staggers and steps over. And it also shows the closed breps that are in it, and then getting a little more into the param viewer as a tree and also as param data. You can do that just by clicking, or you can right click and hit draw tree and draw tree again to return to it. So that's 14, so let's keep going. The 15th, which is really like my earliest scripts, this was one that I really played with, and I've got a mesh on here right now, which isn't so exciting. It just moves a lot faster, but it's that simple script that I showed you before to build that helix. Take that helix, do a rotation under certain amounts of pi, and this is really kind of almost hard-coded in at 0, 0.5, 1, and 1.5, and then a little bit of mass on the point to just draw a point out that moves, that's parametric back to the first driver, so I can kind of move that up and down to have this kind of 4 rotation. A distance between it, moving that, doing a polyline, and then just building a mesh from a mesh pipe, which allows this to kind of do a flow component. I think it's a flow component, but you can kind of see through the center of it. Nice little geometry, fun and fast moving. It might be nice for simulations. I just thought it was interesting. So 15 and 16. We're just going to go to 20 on this, unless that was 6. No, that wasn't 16. Now this one's pretty clumsy, and I think this is just a silly one that I did. But it literally is like a boat, and it's so slow moving, but it's how I was thinking, kind of clumsy to start. I not only was building blocks, like if you take a look in here and I bake this, I think this is a good example of like when you make early scripts, you make slow, heavy scripts. We'll leave this. You'll see that that's pretty complex. I'll take it to a render, if it'll render. And you see that these kind of blocks are like these weird sign-shaped blocks that I made, but I basically started to compile multiple scripts. So you get the first one that drives a geometry, a single phase cosine, and then I think I did a double phase with a little more scripting to drive a curve point, the height of the plank, the indices, to basically build a extruded form, which is, let me take this off because we don't need to bake it. We can just take a look at this item here, and there it is. It's basically building a kind of sine-based wobbly curve. And I thought of that as a building block, and it's pretty complex. It probably doesn't have to be as big, and it probably doesn't have to have such a shape, doesn't have to be so high. So I'm just going to lock my solver, bring down this quite a ways, and change it, and I think it'll have less ripples and bumps. There it is. So it's a faster moving script, but it's a nicer block. And so that's a lot of geometry just to build a block, and then I pull it into this kind of hull of a ship, this idea of working, and I found a much faster way to condense this. You don't need to be repetitive your code like this, but I chose to do that, and I'm just placing and moving these, not just in this crazy pattern in one direction. I've got another one that comes out facing the other way in a smaller form. And I thought the two of those kind of worked well together like this. I think I left something in here hovering. Let me see if I can pick it up and get rid of it. Oh, that was just from the last script. So kind of a fun little toy block Lincoln log assignment, but it's where I was thinking of building and driving forms. That was 16. Let's go to 17. Like I said, these are the earliest scripts and how I was thinking about learning Grasshopper. And I usually read a script from the end, and I like these little sine, cosine, single phase, and double phase coins. I actually think they're quite beautiful, and for some reason as a sculptor I prefer to make something as simple as this. And there it is, a nice geometry that runs, becomes this nice form that you can play with and change when you want. And I think it would be nice to manufacture in bronze or stainless or steel or cast iron. But as a device, basically it's a moved component. Let's go back to the beginning now and see how it's built. From curves, you get a point system right here to drive the front. From curves, you get the points to drive the back. You interpolate between the front and the back. You loft those together, you get a kind of fun shaped surface, you extrude that up, and from that you find the centroid. You simply bring in a disc and you do a little movement of it, and you do a solid intersection. And so it's not too hard, just using some base geometry to make some complex geometry to produce what I think is a cool little design. But that's just kind of what I spent my time on. So that was 17. And we'll go to 18. Like I said, these are the earliest works. I think anybody getting in the Grasshopper should play off of this. Then I started to play off a kind of wheelbarrow. I wanted to have a funky little thing that I could control. And it really is how I've always thought about building now, all the way to my most recent work, thinking of ChatGPT. Drive the curves. Produce the curves. If you like your curves, this curve, and this curve, then those curves could be dictating for a nice loft and extrusion, a nice form like the back of a chair. Now I think these curves can be generated out of Visual Studio Code or from ChatGPT. You can drive some nice little forms and wheelbarrows. Then I did a little move. The other shapes were these, which then became a similar structure of building this component, which I think is the negative of this excuse me, this form Boolean differenced into that. And then I think I probably made two more forms for the legs, and they all kind of come together into one merged kind of document of moving and orienting and playing around. It's clumsy, it's slow, but it starts to build a pretty interesting kind of wheelbarrow design. And these are some of the early CAD pieces that I hope to take into some experimentation and then mesh with and think about entering programs like N-topology. So that's very exciting to me. And then I want to fab these from the get-go as NURBS out of surfaces and then bring them into meshes. Let's just go over here and finish up with the last two of my early scripts that I find interesting. They're certainly not my first. This is one, and I guess I called it parametric wheel. So you've got these. Oh, this is kind of fun. You're making geometries and you're kind of bringing them. And I think I did something with some maths over here, and I did another thing here. So it looks. I can kind of guess where this is going as a surface, and then I'm left with this kind of tool in between, and this wonderful little. So I've just jazzed up my other piece by allowing a lot of parameters to come in and play off of. How am I going to run this? And it's very slow moving here, so I'm playing off of those double sine phase, and looks like I did a bad job in cutting it off, so I better be careful with that. Probably was set nicely at 20, and you can see that I flattened this side a little too much. And then you've got some number counts, probably something simpler here. I could get the holes down to like 4. Yeah. And so it's just like a slower moving script to build a kind of interesting design with negatives, or you could even pull from the negatives to do something. So clumsy but early script, using the maths I like and how I think about Grasshopper to drive curves, to drive surfaces, to drive solids. And these will all be on my private repo for my earliest scripts. Every 10, the public ones are the ones that are ones I've found online or I've modified a little bit, and then every other 10 will be my own kind of crazy scripts as I'm interested. And the last one I put in here, I just put it on. I really like it. It's just a nice little tool that I can hand to my kids to play with. Pretty fast moving, pretty articulating. What you want to do is these two wheels to fabricate. I just think it's a great use of node scripting to understand what you need to do, and then this can be carried farther into other softwares, which is where I'm going to go with it. And we'll see what ends up happening, and I could reverse that. Sometimes it breaks and becomes negative, but then again, why wouldn't you want a wheel for some reason that has traction if you wanted to bring it out and have it, well, maybe not, that's not the best example. The best example would be taking the radius of the hole radii and cranking that up till you bust through, or do something with it. Anyway, I just leave those as my first 10. They're pretty exciting. They're in my private repo. They're easy to follow, easy to just follow through and see what's happening with geometries and surfaces and intersections and a little bit of pi and rotations and a little bit of transformations, and you're left with a pretty cool script. So that's it for that. I think what I'll end up opening is where I'm going to go. I think I've made videos all the way through till 50, and then I'm back into Wickerson Studios here, but I want to take off with a Daniel Christoph script at 61, which is just beautiful, I'm sure, because all of the work he did early really motivated me, and his scripts are awesomely cumbersome, and this is his weave pattern, which I absolutely adore. And we're going to let it load up, and you can see that I have a wonderful lattice work that can be fabricated by learning the weave. And this is actually a lattice work that's based on just a curve. So the script itself comes out of here, a nice structure of these objects turned into these patterns, turned into these patterns, turned into this pattern. So you can just select 1 as the curves, 2 as the curves, 3 as the V curves, and 4 as the V curves. Then you're bringing those two together, this one, and then you're bringing them into that final form. And you can put these into subdivisions and all these wonderful things as well. But the best thing about this is, and I will get to this, is you can change your curve up. You can follow some beautiful curves, and we're just going to plug this in here and see how fast it runs. Set one curve and wait, and should be bamf in a minute. It might take 4 seconds. Yeah, that's about it. So you get another nice pattern that you can build an interesting woven lath work of building. And you can change the scale of that and change all these variables as you go through it. So I will get into that as the next series, and I also will get into processing the next set of Wickerson scripts, which start here at 31 to 40. Once again, those will be in all the videos will be up on YouTube, and all those videos will be on a GitHub repo, and I'm going to alternate back and forth from my repos right here. The first 10 will be, and then skip next first 10. 10 after that will be private, modified, then there'll be inspired 10, and then modified, and I've got thousands and thousands of scripts to go through. So I hope people find it helpful, and I'm going to jump back and forth from newer work the entire time as well. So stop recording, stop streaming.